Good afternoon, everybody, and welcome to MOS Live, our virtual planetarium, The Sky Tonight. My name is Karen. I'm one of the many educators at the Museum of Science, and I'm going to be acting as your moderator today. That means I'll be keeping an eye out for all of your questions, observations, and comments as we go through a model of the nighttime sky tonight. So in a moment, we'll meet our actual planetarium educator who will be taking us through the view of the nighttime sky. But just a couple of quick housekeeping things. Number one, if you're here on Zoom and have a question or an observation, you can use the Q&A button. Just click on that and type in your comment or question. If you need closed captioning and here on Zoom, you can find the CC button and choose Show Subtitles. Now, if you are tuning in via Facebook or YouTube Live, we're super excited that you're here and checking us out. Unfortunately, we cannot field questions or comments from either of those locations. So with that, I think it's time to dive right into what we can see in the sky. So thank you, Katie. You can go ahead and introduce yourself.
Hello, everyone. My name is Katie. My pronouns are she and her. And today we are going to be talking about quite a few different topics because there was one really awesome event or announcement that happened this week about Venus, and I want to expand on that a little bit. And I also want to talk about some constellations that are up in the sky around the same time when we can see Venus. So I'm going to share my screen and we will head into Stellarium. So this is the program that I'll be using today. It is free to use, free to download. If you're interested, you can find it at stellarium.org, and we'll have that link for you at the end if you are interested. So right now I have this set to, we're kind of looking at the southeastern part of the sky, and we're viewing from Cambridge, so mid-northern latitude. The sky will be fairly similar if you're kind of anywhere near those mid-northern latitudes. And I've also set this for 5 o'clock in the morning. So I know it's really, really early. You'd have to wake up. It's not the ideal time for stargazing, but there's a lot of really cool constellations that you can see at this time and planets, which is why I chose this time. So if you wake up really early or you like to pull all-nighters, then you will be able to see a lot of these constellations. Another thing that you can do to see these constellations is just wait, because as we get into the fall and the early winter, these constellations that you're seeing right now at 5 o'clock in the morning will be visible earlier in the night at a more reasonable time. So I do want to talk a little bit about why you see different constellations at different times of the year. But first, let's make some observations, see if you recognize anything in this part of the sky, if you recognize a star or a planet or a constellation or really anything. Just feel free to type it in the chat and we'll get it started. And if there's nothing that you recognize, feel free to put a question mark. That's totally fine too.
There's nothing coming in just yet, but I think I recognize something. Ooh, and it's the same thing someone just typed in. Orion, question mark, question mark.
Yes, so that is probably the most prominent constellation that is visible right now in the southeastern part of the sky is Orion. And the easiest way to look for him is to look for the 3 stars that make up his belt. So if you're looking right here, you can see the 3 very bright stars. I can zoom in, get a better look. So that's his belt. And then from there, you can find the rest of the constellation. So we can come up here to find one of his shoulders. Here's another shoulder, 2 legs, very teeny tiny head up here. And then he's a hunter according to Greek mythology. So he has a kind of like a bow and arrow or a shield that you can see in this kind of arc of stars here. So if I click on one of the stars in this constellation and then put the lines up, you can see it a bit better. So I like to joke that this is actually one of the more familiar constellations that actually looks like what it's supposed to be, even though it still is kind of a stretch, just because a lot of the line artwork for the constellations really doesn't look anything like what they're supposed to be. So we have to really use our imaginations to figure out what the Greeks and Romans were looking at when they were looking up at the night sky. But normally we refer to Orion as a winter constellation. And that's because the best time to view Orion is in the winter time, and it's at a reasonable time. So basically, from the time it gets dark to around midnight, that's a really good stargazing time, just because it's the easiest time to go outside and look at the sky. So that's when Orion is best viewed, is in the winter months around those times or within those times. But that's not the only time you can see him. So the reason we have seasonal constellations is because the Earth moves around the sun. So in different seasons, so different parts of or different times of the year, the nighttime side of the Earth is facing different parts of space. So in the summertime, the nighttime side is facing, one chunk of the sky, but the daytime side of the Earth is also facing another chunk of the sky. But you can't see any of those stars because the light from the sun and Earth's atmosphere is blocking out the light from all those stars. So that's why you can't see any stars during the daytime. But if you could, so say we didn't have an atmosphere or something like that, you'd be able to see all of the constellations that are visible in the northern hemisphere just at different times of the day. So as we move closer into autumn and the fall, lots of these constellations, these prominent winter constellations, are starting to be visible in the wee hours of the morning. And the later we go into the year, the more we will see it rising earlier and earlier, and eventually at a reasonable time for us to go outside and view them. The winter sky is awesome. There's so many bright objects. As you can see, this particular patch of the sky is what I'm going to be focusing on today. And Orion is definitely kind of steals the show of the winter sky. So I want to point out a few more objects that are in Orion. Some of my favorite objects are located in this constellation. So if you look near his belt, there's kind of a smudgy area. It almost looks like a cluster of stars. But if we take a closer look by zooming in, you'll notice that it's actually a giant cloud called a nebula. So there's all different types of nebulas out in space. The term nebula it refers to just a giant, very pretty cloud of gas and dust. And when I say giant, we are talking, tens of light years across, sometimes even bigger than that. Sometimes it's hundreds of light years across. And these are areas where stars form. This particular nebula, anyway, is a nebula where stars can form. So the gas and dust within these clouds are very cold and dense, so it clumps together really easily and gets bigger and bigger, kind of like a dust bunny, until all that material collapses and forms a star. Pressures and temperatures rise within the clump of gas and dust to the point where you have materials smashing together, and that basically ignites the star and then kind of fuels it over the course of its life. So there are lots and lots of stars forming in this nebula that is conveniently named the Orion Nebula. All right, so that's one really awesome thing happening in Orion. If we look at his shoulder up here, you'll notice a really, really bright star. And you might even notice something else that's a little bit different about it. So if you notice anything weird about this star, go ahead and type it in the chat.
While we're waiting for that, do you know what gases nebulas are formed of?
Yeah, so most of the gas in the universe is hydrogen. And hydrogen, when it condenses, like in a nebula to form a star, as it condenses down and the pressures get really, really high, it can smash together. And when you have 4 hydrogen atoms kind of colliding, then you can form a slightly heavier element called helium. So hydrogen is the most prominent gas in the whole universe, and it's what makes up most of these nebulas, but there's also helium and some heavier ones as well.
Awesome. And that gave plenty of time for people to start making some observations and predictions. So a couple of them, somebody says it's a different color. My guess is it's a yellow star and it's yellow. I think they're all great observations.
Definitely. Those are great because it's got a different color than a lot of the other stars around it. It does have a yellowish hue to it, but sometimes it looks a little more orange or reddish, kind of depends on when you're looking at it, just by the, the conditions around you, the atmosphere, things like that. But the reason it has a different color is because it is a red supergiant star called Betelgeuse, which translates to armpit of the giant. So it's one easy way to kind of remember its location in Orion. And it's a supergiant. So that means that it is one of the largest stars. It's very, very massive, much more massive than the sun. And another fun fact about it is that it is nearing the end of its life. And when really massive stars start to run out of fuel, they explode, they go supernova. So that is in Betelgeuse's future. It will eventually explode soon. But when I say soon, I mean within, maybe 100,000 years or so. That's pretty soon on the time scale of a star. All right, Kara, do we have any questions so far?
Well, there's still one I've been hanging on to. When you originally asked for observations, someone asked in that wide sort of swath of the sky, is there a planet and or a yellow star, which may have been Betelgeuse that we just met, that particular attendee was looking at, but no other questions.
All right, so if you are looking at, and there's many bright objects in this part of the sky, and two of them are planets. So if you were looking over here, that is a planet. And if you were looking over here, that's another one. So I'll get to those in just a little bit, but great observations. They are very bright in the sky. And really, if you view any time from the time it gets dark to the wee hours of the morning, there are planets to see. So right now is a great time for looking for planets. All right, one other thing I want to point out in Orion is his foot here. So this is a star that has another different color. This is a bluish star, another very massive high energy star called Rigel, and it's very, very bright. So we talked about these two stars having different colors. One's red, one's blue. What do you think the color of a star can tell you about it? And again, you can put that in the chat, or if you don't know, you can put a question mark.
Because in science, there are lots of times we don't know. Somebody says temperature, question mark. It's the only one so far. We'll see if we get any more coming in.
Temperature is correct. You can tell a lot about a star's temperature just by looking at its color.
Also, age was a prediction. The type of gas. Sometimes it just hangs up. It takes a while for them to make it to the chat box. So age, temperature, and gas, I think, are the three main observations or predictions.
Yeah. So age and composition of a star can also be, you can kind of indirectly tell those properties about a star based on its color. Examining the light given off by a star can certainly tell you more about those specific characteristics, but even more directly, the color of a star does tell you how hot or cold, in quotation marks, a star is, because stars are never really cold. So red stars happen to be a lot cooler than blue stars because blue stars use up lots of material very quickly. They're high energy. They're kind of like the gas guzzlers of the universe. So blue stars are actually much, much hotter than red stars are, despite what our zinc faucets say. So next time you go out and look at the night sky, these are by no means the only two stars that have different colors. So next time you look out at the sky at night, look out for stars that have different colors and see if you can find more red ones or orange stars, or maybe some blue ones out there. It's always kind of a fun thing to search for. So Orion, we could talk about it all day, but there are a lot of other really bright constellations in this part of the sky. So I'll point out some more, and you can actually use his belt to find them. So if we follow the belt down this way, you'll come to a very bright star. This is actually the brightest star in the whole nighttime sky. It's called Sirius, and we can click on it and learn a little bit more about it. It has lots of different names. And we can see here that it is almost, it's like 8.5 light years away. And if we zoom in a little more, you can see the constellation that it's a part of. This constellation kind of looks like it's all over the place, but if you look at it from the side, so if you kind of tilt your head, it's a little bit easier to maybe figure out what it is. But does anyone have any suggestions about what it might be, or what they think it looks like, what they think it should be?
Someone suggests that it is a dog. And I really hope everybody just tipped their head sideways, because I kind of did it at the same time you did. A very strange dog.
Yeah, that's a pretty good description. It is supposed to be a dog. This is Canis major, or Canis majoris. It's the big dog, which usually means that there's a little one as well. And this is the head of the dog, and its tail and its legs. It's kind of wonky. Strange is a very good descriptor for this constellation. But it does have the brightest star in the nighttime sky, which is Sirius. So if you're a fan of Harry Potter and you know the character Sirius Black, his character comes from this constellation, and he's named after this star, which is also called the Dog Star. All right, now let's use the belt and go the opposite direction. So we just went down, but now we'll go up, and we can follow it up to a what looks like a V in the sky. So there's one very bright star, and then it kind of connects down and forms this little V. This is the main part of the constellation, but there's a lot more that goes with it. So if I connect the dots, you will see that it actually extends out here and even down this way a little bit. So this constellation is supposed to be a bull, Taurus the bull, and these two lines here are the horns of the bull. So this one you really have to use your imagination for. Definitely. But Taurus the bull is awesome because this bright star, this is a bright orange star called Aldebaran. It's kind of like the angry eye of the bull, and it almost looks like Orion is in a great battle with the bull in the sky. And if you see this group of stars here, that almost looks like a teeny tiny dipper. This is actually a collection of hundreds of stars, even though it looks like there's only maybe 6 of them. This is a star cluster called the Pleiades. And if we zoom in, you can see there's actually lots and lots of stars there. It's also known as the Seven Sisters, or Subaru. So if you've seen the logo for a Subaru, it's got the stars from the star cluster. And lots of these stars are blue. They are very energetic, and they're relatively young stars. So great place to point a telescope if you are ever looking in the night sky and you can see it. Look for that teeny tiny dipper in Taurus the bull. So let me put up some constellation artwork to help fill in some of those areas. And you can see these 3 constellation rising over in the southeast. You can see kind of how Orion's in a battle. Sometimes people refer to the Pleiades as like the wound in Taurus's shoulder from battling Orion in the sky. All
That
right. So
answered. Someone had a question about, do you
yeah.
have any stories about the stars like Orion? And you just told one, so thanks.
Yeah, no problem. There are lots of really cool stories behind these constellations, and it's not just from Greek and Roman mythology. There are constellations for all different cultures all around the world that have lots of different stories behind them. And you can even make up your own too, because that's how all the stories started. So there's a lot of cool ways you can use your imagination when you're looking at the stars. All right. I could keep talking about constellations, but since we've got about 9 minutes left, I'm going to move on to the planets. So,
Can I ask you a quick question about the planets?
absolutely. Yes.
So this person said, we are in Tel Aviv. If we looked outside right now, what planets, if any, could we see? So maybe just clarifying if we are in different areas of the world, but on the same night, do we see the same sky?
Yeah. So it the changes really happen depending on your latitude. So if you're in the northern hemisphere, chances are you're going to see, a lot of the same constellations. If you're at the North Pole and someone's at the equator, the sky's going to look pretty different. But if you're anywhere in between, you're going to see a lot of the same familiar constellations, at the same times of the year. Now, if you're in the southern hemisphere and you're pretty far south, so in the southern tip of Argentina or Chile or South Africa or Australia, places like that, you're going to see a lot of constellations that you wouldn't normally be able to see up here in the northern hemisphere. So if you go down there, you will actually see a whole new sky. Some constellations overlap, like the constellations that are really prominent, kind of in the central region, like the equatorial region. You'll see a lot of those. Orion is still visible in the southern hemisphere. It's just flipped upside down. So yes, you can see a lot of the same constellations, but you also see a lot of different ones. If you're in the northern hemisphere, though, and I don't know what the latitude of Tel Aviv is,
I
but I
just
have a
looked it
feeling
up
it's
because
similar.
I wasn't sure exactly where. It is farther south than I thought compared to where we are in Boston, but
Okay.
still well above the equator.
Okay, so
That makes
yeah,
sense.
so in terms of planets and constellations, you're gonna see the same planets at the same local time for you as you would, viewing from where I am at the same time.
Also,
So
super awesome that we have some visitors tuning in from Tel Aviv. So thanks
yeah,
for being here, friends.
I love that. That's so exciting. All
Oh,
right,
32 degrees north.
32
They
degrees
just
north.
gave us the coordinates.
Okay, so we're about 10 degrees farther north, I think.
Yeah.
All right. Yeah. So it'll be shifted a little bit, but you'll still be able to see all the different planets if you go out at the same local time for you. All right. So this planet over here, I'm going to start with this one, just mentioning it briefly. This is Mars, and you can tell because it does have the reddish hint to it. And for a long time, astronomers and, engineers and planetary scientists, we were always looking to Mars to see um, if there was ever life on Mars, because in a lot of ways, Mars looks like it had maybe it used to be a little more like Earth. It had a history where there was lots of water on the surface of Mars. There's evidence for lakes and oceans. And so we tend to focus a lot of our attention, at least in terms of, looking for life on other places, to Mars, just because it seems like, well, first of all, it's the easiest planet for us to send rovers and orbiters to. So that's always helpful. So that's one reason we look there. And also it just, is a fairly easy planet to study because it has a thin atmosphere. You don't have to worry about, your rovers crushing on the surface because of all of the atmosphere with atmospheric pressure. And so we usually kind of focus on Mars. But something very exciting happened earlier this week where planetary scientists were studying the kind of upper atmosphere of Venus and found something very exciting. So we were just looking at Mars in the southwest, but if we turn our attention to the east, you can see Venus. And again, this is at 5 o'clock in the morning, so get up nice and early if you want to see it. And we can zoom in so you can see what Venus looks like. And Venus is actually the closest planet to the Earth when they are kind of lined up. But it is one of the harder planets to get to, because if we send a spacecraft toward Venus, it has to deal with the sun's gravity pulling on it. So a spacecraft will actually speed up quite a bit from the sun pulling on it if we send anything there. So it actually takes a really long time to properly plan out a spacecraft to orbit Venus. So it takes a lot longer than expected. But also Venus it doesn't sound like a great place because it has a really, really thick atmosphere, mostly of carbon dioxide, and it's really good at trapping in heat from the sun. So Venus on its surface actually has temperatures of over 800 degrees Fahrenheit. And because of all of those layers of atmosphere, it creates an immense amount of pressure. So if you were on the surface of Venus, if you were standing on the surface of Venus, it would feel the same as if you were 3,000 feet underwater here on Earth. So that's another reason why a lot of scientists and engineers haven't really been able to send spacecraft to land on the surface of Venus, because it would have to withstand extreme temperatures and extreme pressure. But we've been looking at it with telescopes quite a bit, and astronomers found evidence of a gas called phosphine. Earlier this week is when they announced this finding. Now, it's exciting because phosphine is a fairly rare gas. The only places where we really see it made are deep within the atmospheres of Jupiter and Saturn. It's not really a similar environment to Venus at all, but we've seen it there. We've also seen it be made industrially here on Earth, and some of it can be made from volcanoes and lightning and things like that. But the majority of phosphine comes from biological sources, so life. That's how we know its source to be here on Earth. And so finding all of this phosphine in the atmosphere of Venus was pretty exciting, because it was found in amounts where the only explanation that we have right now that could produce this much phosphine in such large amounts would be from biological sources. And we're talking about like bacteria and things like that. And so I'm not saying, and astronomers are not saying, that there is life on Venus, but simply we don't know of another way that this much phosphine could be present in Venus's atmosphere. So it means a couple of things. It means that maybe there is microbial life on Venus, which is awesome. Or maybe it's a whole new field of chemistry that we don't know about, which is also really exciting. So this was a big discovery. Does not mean there's life for sure on Venus, but it's a reason to keep investigating and sending more missions to Venus. We've neglected it for too long, so I'm excited for Venus.
It's one of our closest neighbors.
I know, our sister planet. All right, well, I think I'll turn it back to you, Karen.
Excellent.
Yeah.
Yeah, because I realized that we are pretty much out of time, which is always so sad. And I could talk about space for hours on end if folks didn't realize that I too was as excited as Katie was about the things. But I want to thank Katie for sharing the night sky with us. And I love that we got some international news about it as well, of what you can see from elsewhere in the world, always important. And Venus, I can't wait to hear more about it and just find out if there's any way we can discover if there's any biological functions on the planet itself. So thank you, Katie. And
thank you, everyone.
Next time. And I want to thank everybody else for being here today. We certainly can't do a show without an audience. It's always more fun when you guys have your comments and observations and questions. So thank you all for being here on this fabulous Friday afternoon. If you want to know more about what we are doing for the museum, you can check out mos.org/MOS at home. And if you enjoyed this presentation or any of the presentations perhaps you have seen by the museum, we appreciate any support you may be able to contribute, and you can go to engage.mos.org/welcome. But until next time, have a great Friday afternoon and a great weekend. Thanks again.